Today we want to talk about the power series. So let's look at the definition of the domain of convergence. So the domain of convergence of the power series, the sigma k from 0 to infinity of c sub k x to the k's power, is the set of all x values such that this power series converges. Okay, so let's look at remark. If we define this function, this series by a function f of x on the domain of the convergence, then this series, this power series, is called the power series expansion for this function f on the domain of convergence. So now let's look at one example. We give a power series which is the sum from k from 0 to infinity of -1 to the k's power times x to the k over k plus 2. We want to find the domain of convergence. Okay, so you should be very familiar with this kind of problem because we have learned this kind of problem in the calculus 2 already. Okay, so now let's look at how we do that. We use the ratio test. Okay, the ratio test. If the ratio less than 1, convergence, absolutely convergence. If the ratio greater than 1, divergence, right? If the ratio equals 1, then we need to consider other different cases. Okay, so let's take the ratio, right? This is the ratio limit k approaches infinity of the n plus 1's term, right, over the k plus 1's term over the k's term, right? If you take the ratio, so you will see it's equal to the limit k approaches infinity of k plus 2 over k plus 3 times the absolute value of x. So since this is the limit about k, so this term would be 0 if you take the limit k approaches infinity. It would be 1, so it's 1 times the absolute value of k. Okay, absolute value of x. So you have the result is absolute value of x. So now, based on this calculation, we need to discuss the different cases, right? The first one, if the absolute value of x is less than 1, so it converges, right, by the ratio test. If the absolute value greater than 1, then this series diverges, right? So now we need to consider the absolute value k of x equals 1. So we have two cases, right? X equals 1 or x equals -1. Okay, so now let's look at if we let x equals 1. Okay, equals 1. We put x equals 1. Then this series, this power series becomes this series, right? We are very familiar with that. This is the alternating series, right? By the alternating series test, this series converges. So at 1, it still converges. What about x equals -1? When x equals -1, so the series becomes this one, right? So it diverges. Because if you, of course, there are many ways to identify its divergence or convergence, right? It's very similar to the 1 over k, right? So you can also use that way to consider its divergent. But over here, I use the integral test. So we take the integral, right, from 0 to infinity, right, of 1 over x plus 2, then it's equal to the natural log of x plus 2, then plug in infinity and 0, then you will have the infinity. That means it's divergence. Okay, it diverges. So the domain of convergence, sorry, so it should be the domain of convergence is equal to -1 to 1, and -1 is open and 1 is closed.